Morning. This is pre-calculus. We are going to work on learning target 3.1, adding and subtracting rational expressions. So we are also going to find the discontinuities here along the way. I've got these two fractions here. I want to try and make my fraction addition a little simpler. So I'm going to look and see if I can reduce. Sure enough, up here I have a 2 times r. And down here I have a GCF of 2. So I'm going to pull out that GCF of 2. And then I'm going to have r squared minus 3r plus 2. And the whole point of doing that is so that this 2 times the trinomial, that 2 can cancel with this 2 times r. Only cancel common factors that are multiplied together. So my new left-hand fraction is going to be r over r squared minus 3r plus 2. Over on the right-hand side, I have this 3 times r divided by 3. Well, 3 divided by 3 is 1, so I just have a fraction of r over 1. I need a common denominator to add these fractions together. I'm also going to wait to factor this trinomial for my discontinuities. It's a lot easier to distribute things to a trinomial than it is to two binomial factors. So, looking at my denominators, they have nothing in common in this problem. So over here, I'm going to multiply r squared minus 3r plus 2 on top and bottom. Okay. And then over here, I could multiply by 1 over 1, but that doesn't do anything mathematically to help me. So, because 1 times anything is itself. So, now I have a common denominator. R squared minus 3r plus 2 is going to match 1 times r squared minus 3r minus 2. Common denominator. Check. Okay. So, we have r divided by r squared minus 3r plus 2 plus... We're going to distribute the tops, the numerators. We've got r cubed minus 3r squared plus 2r. You are very frequently always going to distribute and combine like terms in your numerators. Denominators, you wait to do all that. My denominator for this fraction is the common denominator, r squared minus 3r plus 2. Now that I have a common denominator, I add my numerators together. I combine them. So this like term of r is going to combine with this 2r to make a total of 3r. So first we're going to have r cubed plus, oops, not plus, minus 3r squared. And now the like terms of r and 2r make 3r. Come down here, my common denominator is r squared minus 3r plus 2. Check this problem, see if we can do any kind of further reducing. We don't want to cancel anything because this is subtraction, adding. We can only cancel things that are multiplied. Okay. Yes, I can pull a GCF of r out up here. But is there a GCF of r in the bottom that I can pull out? No. So there's really no point to pulling out that GCF. There's no benefit. So we're just going to leave this numerator. The last thing we need to do is we need to do our discontinuities. Discontinuities are going to come from the denominator. So we're going to x factor this trinomial. We've got 2 minus 3. That's 2 and 1. Negative, negative. So my top stays r cubed minus 3r squared plus 3r. All divided by this factorization, r minus 2, r minus 1. Remember, r times r will get us the first term, r squared, every time. So whatever goes in this first 2 spots should always check to be r squared. All right, so our discontinuities are positive 2 and 1 because those are the zeros of the denominator. Okay. And this is our final answer. Okay. Let's do one more example. All right. So just like before, we want to try and reduce things at the beginning if we can. I do see a subtraction sign this time, so I'm going to make this plus negative 6k plus 6. I'm going to change the signs of the numerator to the fraction to the right. Look here at 5 divided by 3k. Can I simplify that? 5 divided by 3 doesn't simplify. There's no k that cancels. Nothing to do here. Let's see. So here I can pull out a minus 6. So let's do that. And then I'm going to get k minus 1. Remember, if I'm pulling out a negative 6 GCF, this operator, this sign is going to flip. Looking at 2k cubed plus 14k squared plus 12k, there is a GCF of 2, plus there is a GCF of k. So we're going to pull those out. The reason why the 2 is going to be advantageous is because it's going to cancel with that GCF of 6 up top. So 2k pulled out is going to then leave k squared plus 7k plus 6. The only reason why we chose to factor this step is because we wanted things to cancel. If there's nothing that's going to cancel, there's no point in factoring the denominator right away. Wait. So here we've got negative 6 divided by 2, which is going to be a negative 3. And this k isn't going to cancel with anything, so we'll just leave it. And for simplicity's sake, I'm going to distribute that back in. So I've got 5 divided by 3k plus negative 3k plus 3 on top now, because I distributed that minus 3 in. My new denominator is k squared plus 7k plus 6. Now we are ready to try and add these fractions together. Well, looking at the denominators, they are very different. Okay? But there are elements in common. So there's a k in common. So when we multiply on the left-hand side, I don't need a k in this denominator. So I'm only going to multiply the left-hand side by the trinomial, k squared plus 7k plus 6. And make sure we do that on top and bottom. So you can look now at this denominator. This denominator is k squared plus 7k plus 6 times 3 times k. We still need to multiply over here by something. Okay. So ignore this stage for now. Okay, imagine that didn't happen. We already know the k is in common, so both denominators have k. But this side doesn't have the 3 that's over here, so we're going to multiply this side by 3 over 3. Now if we look at our denominators, k squared plus 7k plus 6, 3k. Each one of those 3 elements is present in the denominators, which means we have a common denominator. Now I'm going to distribute my numerator. I'm going to back distribute the 5. Notice I didn't factor the trinomial. Leave it in standard form so it's really easy to distribute. So I've got 5k squared plus 35k plus 30. Distributing this 3 on the right, we're going to have minus or plus negative 3k, nope, 9k. Plus 9. And then we have our denominators. I'm going to put the 3k GCF in front, always. Okay, and then same thing over here. The 3 and the k come together. And k squared plus 7k plus 6. Hey, common denominators. So now all we have to do is combine our like terms. Well, this minus 9k and this 35k combine together. So we've got 5k squared. 35 and minus 9, what is that? That's positive 26k. And 30 and 9 make 39. That is our new numerator. And then the denominator is a 3k and this k squared plus 7k plus 6. Okay, let's look and see if we can reduce anything. So I've got a common GCF of 3. Can I pull a 3 out of here? Nope. I've got a GCF kind of k. I cannot pull a k out, so nothing's going to distribute here. I'm not going to AC split that top. That's probably not going to work. I could check the discriminant and see if it's a perfect square. It won't be. So the last thing to do is find our discontinuities from the denominator. So this trinomial, now we're going to factor it. So 6 and 7, 6 and 1. So our denominator is 3k, k plus 6, k plus 1. And our numerator stays the same of 5k squared plus 26k plus 39. Our discontinuities, we have 3 of them this time because we go by the k values in the denominator. We have k is 0 from here. We have negative 6, and we have negative 1. Final answer. Hope you guys enjoyed watching these videos. We will do an multiplying and dividing one next.